This is 9.1, solving quadratic equations using graphs and tables. Earlier we talked about, I showed you a picture when my boys were younger, and a lot of times when objects are being thrown, what you need to do is envision a graph and like literally how high is that person throwing the ball or kicking the ball. And it makes an arc of a parabola, makes the shape of a parabola, and you can literally see this, going from the ball's leaving. You can see it's leaving about right here, and it's being traced up here. It's going to land, approximately like that, and you can see the height of it. The height of it is like here. Again, if this graph was true, the graph's a little bit off, but envision a piece of graph paper. Every time you look at, you hit a golf ball or kick a soccer ball, how far is it going? Where's the middle of it? How high is it going? And that's literally making the shape of a parabola. And so we already talked about that back in chapter 8. So chapter 9 goes a little bit more in detail about it. So let's talk about solving quadratic equations. And first of all, a quadratic equation are equations to the second degree. So we've already talked about that. So anything to the second degree is a quadratic equation. Solutions, we've been solving equations for a long time, but just as a reminder, a solution is the value that makes the equation true. So whatever makes that equation true, that's called a solution. And we've already talked about these three words, the x-intercepts, the roots, or zeros. They all mean the same thing. It represents the solutions of the quadratic equation. It's where it hits the x line. And that's what we're going to be looking at. So find the solutions to this quadratic equation. So again, solution means where, what will make this true? When will it hit the x line? So if we started graphing this, we could make an XY chart, and we could substitute some numbers in if we wanted to. So if we plug 0 in, we're going to get negative 16. If we plug 1 in, we're going to get negative 15. We're going to plug 2 in. We're going to get, again, all I'm doing is 2 squared minus 16. So that's 4 minus 16, so you're going to get negative 12. So I'm just plugging these numbers in. If I plug 4 in, let's say, 4 squared is 16. 16 minus 16 is 0. And then also, if you notice something else, you remember, once you find the axis of symmetry, it's reflective. And so, and 0 happens to be the axis of symmetry. So literally, I could put negative 1, negative 2, and negative 4, and it would literally be reflective. And so if I started graphing this, and let's say we're counting by 2's here on the y line. So negative 4, 0, I'm counting 1's on the x line, but negative 2's, I'm counting by 2's on the y line. So 4, 0 would be here, negative 4, 0 would be there. Negative 2, 12, negative 2, 12 would be here, and 2, 12 would be here, and 0, 16 would be here. And then you would just make that parabola. And it would look like that. So we graph it. Now, when it says find the solutions, what we're trying to find are the x values that make it true. So literally, x equals what? And remember, x equals what? So we're trying to find out what values will make it true. Well, remember what solutions are. It's where it hits the x-intercepts. So it literally hits the x line at positive 4, and it also hits it at negative 4. Right there. Those are your zeros, okay, or your x-intercepts. So the solutions would be x equals 4 and x equals negative 4. And again, you can see it on the table as well. That's where the zeros are. So let's look at another one. So find the solutions to this. So again, if we made an XY chart, and again, without a calculator or with a calculator, either one. So remember to find the axis of symmetry, x equals negative b over 2a. And again, remember your ABC. So a is, let me get a highlighter out. A is your 1, b is there, and that's your c. So ABC. So a is 1, and b is negative 14. So negative 14. Oops, let me switch it again. So it's positive 14 over 2 times a, or 2. So x equals 7. So the axis of symmetry is actually at 7. That's the middle of the parabola. So if we plug 7 in to the equation, we're going to end up getting 7, 0. And then if we plug, let's just say, remember, what I would always recommend is choose like 2 numbers. Once you find the axis of symmetry, choose 2 numbers to the left or 2 numbers to the right. So let's choose 6. Let's choose 6, and let's choose 5. Like 2 numbers to the left, 2 numbers to the right. So we're going to choose 6 and 5. So once we plug 6 into this equation, so literally like 6 squared minus 14 times 6 plus 49. And then you see what you get when you do that. When you plug 6 in, you're going to get 1. And when you plug 5 in, you're going to get 4. So if I literally plug 5, 4, or graph 5, 4, and 6, 1, remember, and then we know it's 7, 0, remember it's reflective. So it's 1 space away, that's 2 spaces away. And that's enough. 5 points is enough to graph my parabola. So I have my parabola looking like this. And remember, it says find the solution. So don't forget to actually answer the question. So when it says find the solution, I want to know what x is. And remember, x is where it hits the x line. You're trying to find the x-intercept, the 0. Well, it only hits at one spot, and it's right there at 7, 0. So at 7, x equals 7 is when it hits the 0 line on the graph. So again, if I plug 7 in, 7 squared minus 14 times 7 plus 49, that's the only one, that's the only number that actually makes 0. And that's what you're trying to find, when it will hit 0, when it equals 0. That's what you're trying to find. So let's look at find the solutions of this problem. So again, if we made an XY chart, and first of all, what we want to do is find the axis of symmetry. So x equals negative b over 2a. So negative b would be negative 4 over 2 times 1, which is 2. So the axis of symmetry is negative 2. So if you go to negative 2, that's the middle of the parabola right there. And if you plug negative 2 in, so literally put negative 2 into those x's, and then you calculate that, you're going to end up getting 3. Remember, that right there is the vertex. That's the vertex. So negative 2, 3. And then what we're going to do is do 2 numbers to the left, 2 numbers to the right. I'm going to go to the right this time. So I'm going to actually plug in negative 1, and I'm going to plug in 0. So if I plug in negative 1, I'm going to get 4. If I plug in 0, I'm going to get 7. So negative 1, 4 is right here, and 0, 7 is there. And remember, you can reflect it. So 2 spaces away, 2 spaces away. And then I'm going to draw my parabola. Now, I graphed the parabola, but remember, answer the question. The question says find the solutions. So the solution is, where does it cross the x line at? Well, it doesn't cross the x line. There are no zeros or x-intercepts on this one, so this actually has no solution. And again, what that means is there's no answer if I plugged it in. If I plugged it in this equation, there is not one answer that will make it equal 0. Not one. And that's what no solution means. There's not one solution, not one answer that will satisfy or make that statement true. So let's look at using the table to find the solutions. So here we're going to use our calculator. So go ahead and get your calculators out and punch that function in as y equals. So remember, we're always treating this as, you know, a function. F of x equals x squared minus 7x plus 6. And it's the same thing as y equals. F of x is the same thing as y. It's your input and output. Your domain and your range is what you're trying to find. So what we're going to do is we're going to substitute this in. We're going to plug that into our calculator. And we're going to look at the table, because I want to show you something on the table without actually looking at the graph. You can actually find the solutions to your answer. So again, go ahead and push y equals, plug this function in, x squared minus 7x plus 6. Now, again, we could look at the table, or we could look at the graph, but I want to show you on the table what we're actually looking for. So if you notice this, and I'm just going to copy a few of them down just to highlight a few things. So I have 0, 6, I have 1, 0, 2, negative 4, 3, negative 6, And then it keeps going down, but notice you get down to here 6, 0. So something I want to make sure you're aware of, when it says find the solutions, again, notice find the solutions. That means we're trying to find what x equals. X equals what? And again, we're trying to find out what will, when I substitute x into here, what will make it equal 0? What makes it true? And you can see right here and there, right on the table, right there, 1, 0, and down here at 6, 0. See, that's what I'm trying to find are my zeros, your x-intercepts. Without even looking at the graph, I can tell that I have my zeros right here and right there. So x equals 1 and x equals 6. That's when x equals 1, x equals 6. That's when it actually equals 0. So you can look at the table and literally find your zeros when you do that. Now let's look at another possibility here. It says use the table to estimate. Because sometimes when you actually look at the table, you can't actually see it. And I'll show you. So we're going to plug this in, 3x squared plus 5x minus 2. And then let's look at the table. So remember what this actually means. Remember, this is, you're trying to find when this will actually equal 0. And if I looked at the table on this function, so here's one solution. It's not possible, it is a solution. So x equals -2 is one of the solutions. Remember, it has an x squared, so there's two solutions here that we're going to be considering. So x equals -2, and again, if you look at the graph, you can see it crosses at -2, and then it comes back up, and it looks like it crosses like right there. So in between 0 and 1. Well, again, at x equals -2, it's at 0. At x equals -1, it's at -4. And again, you can see the graph. At -1, it's at -4, so it's down here at the vertex. And then it's going to start coming back up. And then at 1, or at -1, it's at -4. At 0, it's at -2. But at 1, notice it's automatically above 0. So here is below 0, here is above 0. So in between 0 and 1, it is taking place. So you have a negative value, it's below 0, here it's above 0. So again, imagine this is in feet. So this is literally 2 feet below ground, and this is 6 feet above ground. So somewhere in between 0 and 1 is a possible 0. And I just want to remind you that you can substitute this in this table set. You could tell it to count by, let's say we wanted to count by 0.1. So if we wanted to, I'm going to start my table at 0. So at 0, you can see it's 2 feet below, and then notice it's still below ground, it's still below ground, it's still below ground right here, and then all of a sudden, it's above ground. So you know now you can get more exact. It happens in between 0.3 and 0.4. And so you can approximate, x is approximately at 0.3. If I ask you to approximate, you can literally see it on the table. It's right around 0.3. It's in between 0.3 and 0.4, but it's closer to 0.3, right? So that you could literally estimate it by that way. Now, the other way to do this, if I ask you to Francis hits a golf ball at this function, and x is considered this time, how long is the ball in the air to the nearest hundredth? And we've done these problems before, so go ahead and plug this function in, and then if you push graph, you'll see that it hits approximately around 5. Now, I actually want to the nearest hundredth place, so I actually want to find where it hits the ground at, like right there. And so you do second trace, and you want to find the 0 value, and then you're basically going to do left bound, right bound guess. You're going to move this over to approximately, notice the x value, it's getting close. So here's at 5-1, so 5 seconds, it's 1 foot off the ground. At 5 seconds, it's 1 foot off the ground. That's what it means. That's my left bound, so I'm going to treat that as my 0. I'm going to go to the left of that, press enter. Go to the right of it, press enter. Go back and guess where it might be. And notice at 5.04 is your 0. That's 5.04 seconds is exactly where it hits the ground to the nearest hundredth place.